An accelerometer is an ubiquitous device these days. Yes, it is present inside your smartphone. It is there inside your car. इस फोन को जब आप टिल्ट करते हो, ऐसा हॉरिजॉन्टल पोजीशन में लेके आते हो या हॉरिजॉन्टल से वर्टिकल पोजीशन में लेके जाते हो, तो इसके अंदर जो एक्सेलरोमीटर बेस्ड सेंसर है वो फोन को बताता है कि भाई तुम स्क्रीन को टिल्ट कर लो. आपकी कार में एक इंपॉर्टेंट सेफ्टी डिवाइस है एयरबैग, और उसके डिप्लॉयमेंट को इनिशिएट करता है एक एक्सेलरोमीटर बेस्ड सेंसर. ऐसे छोटे माइक्रो इलेक्ट्रोमैकेनिकल सिस्टम्स, एक्सेलरोमीटर्स, इनको डिजाइन करने के लिए आपको इंजीनियरिंग पढ़ने की जरूरत है, लेकिन जो बेसिक प्रिंसिपल इन्वॉल्व है वो तो फिजिक्स का ही प्रिंसिपल है. आज हम एक ऐसा ही क्वेश्चन करेंगे. आप गलत समझ गए, हम कोई इंजीनियरिंग डिजाइन नहीं करने जा रहे हैं. हम एक बहुत ही मोटा सा एक्सेलरोमीटर का आइडिया लेकर आए हैं जिसपे बेस्ड मैकेनिक्स का एक क्वेश्चन करेंगे, और ये क्वेश्चन सबके लिए यूजफुल होने वाला है, मजेदार भी लगने वाला है, लेकिन क्लास 11th के स्टूडेंट को कुछ शायद ज्यादा ही पसंद आने वाला है. मैं शशि भूषण तिवारी आप सभी का अपने इस चैनल पर स्वागत करता हूं, और देखते हैं हम हमारा आज का ये क्वेश्चन. चलिए एक बार पूरे क्वेश्चन को पढ़ लेते हैं. A car is moving at a constant speed on a curved flat road. There is a simple pendulum suspended inside the car. The pendulum is inclined at 30 degree to the vertical as shown in the diagram. इस डायग्राम को आप कार का एक वर्टिकल सेक्शन मान सकते हैं. आप इमेजिन कर सकते हैं कि यहाँ पे जो कार है वो बोर्ड के अंदर जा रही है. उस कार के अंदर उसके सीलिंग से सस्पेंडेड एक सिंपल पेंडुलम है. हालांकि देखने में थोड़ा कंपाउंड पेंडुलम जैसा हो गया, पर ये सिंपल पेंडुलम है जो वर्टिकल के साथ किसी एंगल पे inclined है. Inclined at an angle of 30 degree to the vertical. As the car moves, the angle changes gradually to 0 degree, and then the pendulum begins to slowly move up on the other side. When it reaches at an angle of 45 degree with the vertical on the other side, the car skids. Oh, draw a rough sketch showing a possible shape of the road. Okay, what is coefficient of friction between the road and the tire? I'm getting out of the screen for a moment. Capture the question. Give it a try on your own. Give it a sincere try. That is my request. इस क्वेश्चन में कई सारे कीवर्ड्स हैं. पहला, car is traveling at constant speed. Speed is not changing. It is traveling on a curve but flat road. The road is not banked. This is a simple pendulum suspended inside the car. It makes an angle of 30 degree with vertical. Okay. As the car moves, the angle changes gradually. There is no sudden change. Actually, the pendulum is not oscillating. This pendulum is in equilibrium in the reference frame of the car right now. But this equilibrium angle is changing gradually. Does it tell you something? Does it? Think about it. And then the pendulum begins to slowly move up. Again, slowly. It begins to slowly move up on the other side. When it reaches at an angle of 45 degree with the vertical, the car skids. Before that, car is not skidding. Only when the angle reaches 45 degree, the car begins to skid. What is the shape of the road? I leave that to you, but of course I'll give some hints. You can trace a possible shape of the road in your notebook. What is happening? Suppose this car is going in a circular. Okay, let us assume that it is going in a circular path like this. Let us assume it is a circle. When the car is somewhere here, its acceleration is towards the radius, towards the center of the circle, and its magnitude is v square by r. What is r? R is the radius of curvature of the circular road. For a moment, I have assumed that road is circular. Okay. Now, in the reference frame of the car, this pendulum bob is experiencing three forces. Its weight force, tension in the string, and a centrifugal force, which is mv square by r. What is v square by r? V square by r represents acceleration of the car. If the car is traveling on a road like this, its acceleration is in that direction. The centrifugal force is radially outward. In this diagram, the pendulum bob is experiencing a centrifugal force in this direction. So this centrifugal force is actually causing this pendulum to get deflected, right? But according to the question, the speed of the car is not changing. V is not changing. V is not changing means this force can change only if R changes, which means the car is not moving on a circular track. It is moving on a curved road, but radius of curvature of that path is changing. According to the question, this pendulum moves like this. This angle is decreasing. That means this force is getting weaker. It is decreasing, and it can decrease only if R is increasing. So radius of curvature of the road is initially increasing, right? Then the pendulum becomes exactly vertical for a moment. At that instant, there is no curvature. Road is almost straight. And thereafter, the pendulum sways in the other direction. It means the road, the curvature has flipped, changed direction. Now the road is not a turning like this, it is a turning like this. So that car is experiencing an acceleration in this direction, and in the reference frame of the car, the pendulum is experiencing a centrifugal force in this direction. So I have given you enough hint. Now you can think of possible shape of a road, or maybe there is there a possibility of road having multiple shapes? Can you think of any shape and draw it in your notebook? That is question, and you must give it a try. What is coefficient of friction between the road and the tire? What is coefficient of friction between the road and the tire? It is important to realize that when the pendulum makes an angle of 45 degree with vertical like this, the car slips. When the pendulum makes an angle of 45 degree, it is a kind of accelerometer. It is detecting, it is measuring the acceleration of the car. When this angle is 45 degree, remember that pendulum is always in equilibrium. It is moving very gradually. It is never swinging wildly. It is never having any acceleration in the reference frame of the car. So this force mv square by r must be equal to mg. Then only this will make an angle of 45 degree, if you all understand this. Resultant of these two forces must be balanced by this tension, and therefore this length of the string along which the tension acts must be exactly opposite to the resultant of these two forces, which means this angle is 45 degree, which means mv square by r is equal to mg, which means v square by r is equal to g. Right? So at the instant when the car skids, its acceleration is g. Does it give you a hint? Yes. If a car is traveling on a circular road, like this, it is not a circle actually, but for a moment we are assuming that it is on a circular path of radius r. The friction force provides the necessary centripetal force. In this question, v, speed of car is not changing, but radius of curvature is variable. It is changing. So if r is decreasing, which simply means this quantity is increasing, which means the friction force will go on increasing to provide the necessary centripetal force. But friction has a limit. Friction in this question cannot go beyond this number. So the maximum centripetal force that the car can get is this number. Therefore, I can say that R minimum represents minimum radius of curvature of the circular track on which the car can negotiate actually, because friction coefficient is mu and the friction force is limited to mu mg. Now, according to the question, according to the observation of the pendulum, we already know that car begins to skid when v square by r is equal to g. So this v square by r, when the car skids for the first time, is actually equal to g. So m into g is equal to mu mg, which means mu is equal to 1. I hope you got it right. Thank you for watching. Goodbye.